Hello everyone, today we are going to solve this integral. So if you look at this integral here, we have sin x minus cos x over 1 plus sin x into cos x plus sin x plus cos x, right? So there are many ways to solve this integral. There is one general method for any function of sin x cos x where you can apply that method. So I'm going to use three methods to solve this integral, right? So this is my method one. Again, if you have any other method also, then please do let me know in the comments. Okay, so this is my method one. So first thing you see here is sin x minus cos x, right? If we try to think sin x as a and cos x as b, then this whole expression is basically a minus b over 1 plus ab plus a plus b, right? And this whole thing in denominator, right? This is basically I take can write this as 1 plus b plus, and from here I take a common, so this is a times 1 plus b, right? And this is basically getting reduced to a minus b over 1 plus a into 1 plus b, right? So now here you can apply partial fraction and you can split this into two terms, or you can also observe this basically uh, difference of 1 plus b minus 1 plus a, right? So basically this whole integral is basically same as I equal to integral 1 over my e was sin x. So this is 1 plus b. So this is going to be cos x, right? 1 plus cos x dx minus integral 1 plus sin x dx, right? Okay. So now this is easy to integrate. So you can either convert this into tan x by 2 and integrate, or you can just here multiply and divide by 1 minus cos x, right? So if I multiply and divide by 1 minus cos x, so this is basically 1 minus cos x over 1 plus cos x into 1 minus cos x is 1 minus cos square x, and that is basically sin square x dx, right? And similarly, this is going to be 1 minus, here I multiply and divide by 1 minus sin x, so this is 1 minus sin x over 1 minus sin x square x is cos square x dx, right? And this is basically 1 by sin square x is cosec square x, and this is basically minus cosec square x into cot x dx minus 1 upon cosec is sec square x minus tan x into sec x dx, right? So this is basically integral of cosec square x dx minus integral of cosec, no, this is not a square, this would be cosec x into cot x dx minus integral, this is sec square x dx plus integral sec x into tan x dx, right? So this is going to be integral of minus cosec square x is basically minus cot x, and this is your cosec x into cot x integral is basically its derivative. This is a derivative of minus, this is a derivative of cosec x, right? So, and here we have minus x, so this is going to be plus cosec x. This is going to be minus tan x, and this is going to be plus sec x plus c, right? So this is my answer. Okay, this is from the method one. Okay, let's look at this method two. So if you look at this term in denominator, we have 1 plus sin x into cos x plus sin x plus cos x, right? So if you look at this sin x minus cos x, this is basically a derivative of this, right? Cos x and sin x, right? Negative of this cos x and sin x, you'll get this, right? So I'm trying to convert this whole function as a something like sin x plus cos x, right? So if you try to observe this here, so you know what is a plus b plus c whole square, right? That is basically a square plus b square plus c square plus 2ab plus 2bc plus 2ac, right? So I'm trying to convert this into, so here I don't have any 2 here, right? So if I multiply and divide this by 2, then this is 2 plus 2 sin x cos x plus the 2 sin x plus 2 cos x, right? And if I write 2 as 1 plus 1, this is 1 plus 1 plus 2 sin x cos x plus 2 sin x plus 2 cos x, right? And this is basically 1 plus, oh, I can write 1 as sin square x plus cos square x plus 2 sin x into cos x plus 2 sin x plus 2 cos x, right? I'm also dividing this by 2, so I will take care of it at later. Okay, so this is basically 1 plus sin x plus cos x whole square, right? So my integral is basically this integral, right? This integral, right? This is basically written as integral. This is sin x minus cos x over. I'm multiplying, dividing by this 2, so I will get a factor of 2 here. And this is your basically 1 plus sin x plus cos x whole square dx, right? And now if you try to put 1 plus sin x plus cos x equal to t, then its derivative, sin x derivative is cos x and cos x derivative is minus sin x, right? Dx is dt, right? So sin x minus cos x dx is minus dt, okay? So this is basically minus 2 dt over t square, right? And this is basically integral of 2 upon t plus c. So basically this integral is 2 over 1 plus sin x plus cos x plus c. Okay. 3. So this is a general method, right? So for any rational function, right, of this sin x into cos x, you can apply this method. This may work, right? So basically, what you have to observe here is I can write sin x as 2 tan x by 2 over 1 plus tan square x by 2 in half angle, and I can also write cos x as 1 minus tan square x by 2 over 1 plus tan square x by 2, and then you can take substitute tan of x by 2 as t. Okay, so this is the general idea for any rational function of sin x and cos x. You can apply this substitution to convert this into polynomial rational function, and then again you can handle the polynomials, right? So yeah, so you try to apply this method here and try to solve it yourself. I have just given you an idea. I'm not going to solve this whole. You try it yourself and tell me, is it working? Okay, so that's it for the today's video. See you in the next video. Till then, bye. Have fun and please subscribe to my channel. I'm going to post more videos like this. Okay, bye.